Okay, so last section of the year, powers and roots. So if you look at your formula sheet, we just learned products and quotients. And now if you look at the last one, it's called the Mobb's theorem. We learned how to multiply, we learned how to divide, but now how do you do a power? Do you see in de Mobb's theorem that it goes r cosine, do I have it right here? It's right here. R cosine of theta plus I sine of theta raised to the nth power. The formula says to do this. You take your r and you raise it to the nth power. That'll be the r value. And what do you do with your theta and your n? You multiply them together, and then you're going to use your calculator to put it into the what form? The x plus y I form. It seems easy, but it kind of gets a little difficult because here are the steps. It needs to be in polar form to use de Mobb's theorem, but it's not in polar form to start with. All of the problems today start in complex form. Then after you put it into polar form, then you get to use de Mobb's theorem, and then you put it back into complex form. So here's the zero step. It's in complex form first. That's the problem. Then you put it into polar form. Then you use the Mobb's theorem, and then you put it back into complex form. A plus bi, x plus yi, exact same thing. Complex, polar, use the formula, put it back into complex. Got it? Complex, polar, use the Mobb's, put it back in. I think I have 3 problems because they're all a little bit different. So, ready to go? So the first thing we need to do, step 1, we need to put this into polar form, which you should be very good at because that's all we've been doing the second half of the chapters, put this into polar form. We need to put this, all of this, raised to the 4th power in polar form. Don't we need an r, and don't we need a theta to figure out what that is? I'm just going to leave the theta blank, and I'm going to leave the r blank and fill them in. All of this needs to be raised to the 4th power. So, in order to figure out the r, isn't the r the square root of a squared, which is 1, plus y squared, which is the square root of 3 times the square root of 3, which is 3. And 1 plus 3 is 4, and the square root of 4 is 2. So we have a 2 out here. The next thing we have to do is come up with the angle. And how do we figure out the angle? We've been doing this forever. Tangent inverse of, and I like working with only positive values because then that will only give me the reference angle. Square root of 3 over 1. And do I have it? Yep, it's 60 degrees. Is that the actual angle? Let's just look at it to figure out if that's the actual angle. X is positive, Y is positive. You need to be in the first quadrant. 60 degrees is the number that we need. So, first step, if it's not in polar form, it needs to be in polar form in order to use de Mobb's theorem. Now that it's in polar form, we can use de Mobb's theorem. It's not that bad of a theorem. All you do with the r is raise it to the nth power. So all I'm going to do is take 2 and raise it to the 4th power. And what do I do with the 60 and the 4? What does it say to do? Multiply them together, right? What's 4 times 60? 240. And 2 to the 4th, I'm going to change the 2 to the 4th to 16. And now, since it started in complex form, they want you to put it back into complex form. All you're going to do is use your calculator. But that's a popular angle, isn't it, 240? So you don't have to use your calculator. But do I let you use your calculator or not use your calculator? I'll just use your calculator. Is that what you guys want to hear? So, whatever the cosine of 240 is on your calculator, multiply it by 16. This ends up being a -8, I think. And this ends up being a negative 13.8 I guess. I let them use the calculator last year. Final answer. Any questions on de Moivre's theorem? I know I'm going to do two more for a reason, so you'll see why we're doing two more. So here's the second one. Whoops. Just to show you that some of these today will already be in polar form for you. You don't have to put them in polar form, so this is a little bit quicker problem, right? It's already in polar form. All of this is raised to the what power? The 1/4 power. So you know that if it's raised to some power, you have to use de Moivre's theorem. So all I'm going to do is take the square root of 2 and raise it to the what power? 1/4, and I don't know what that is. It's going to be weird. Cosine of something plus I sine of something. And how do you get that angle in there? What do you do with the 315 and the 1/4? Multiply them together. Ooh, it's ugly. It's 78.75 degrees. That's what you get when you take 315 and you multiply it by 1/4. You're going to get 78.75. And then I simplified the square root of 2 raised to the 1/4. And when you do that, I'm just going to write it underneath there. It's 1.1 when you take the square root of 2 raised to the 1/4. And then the rest of it is using your calculator, right? Which comes out to be a negative 0.21 plus 1.07i. I think they have equal out to obviously 2 decimal places. Just to show you that sometimes it's in polar form, sometimes it's in complex form. How do you know how to switch them? Yep.
How is it negative 0.1?
It doesn't turn out to be that? Yeah. You're right. It's positive. Because this is in the first quadrant. So it's positive. Thank you, Mariah. Okay, next problem. Okay. This problem, just to show you, you don't have to have positive exponents. You can have negative exponents, right? So you don't have to move this down and go 1 over, what would that look like? Wouldn't it look like something like that if we did the old stuff? But we don't have to do that. So we're just going to do what we just did. And this is going to take a little bit longer because this is in complex form, not in polar form. So this will take a little bit longer, but same concept. So we might as well have fun and do it. So the first thing I'm going to do is find the r. What's the square root of 3 times the square root of 3? 3, and 2 times 2. So doesn't that make 3/4? Plus, this is any time you take a negative number and you square it, it's going to be positive. So 1/2 times 1/2 is 1/4. It turns out nice. The square root of 3/4 plus 1/4 makes 4/4, which makes 1, which is the square root of 1 is. Yay. Good. And then tangent inverse of the square root of 3 over 2 divided by, again, I like just using positives, 1/2. Somebody in 7th hour asked, how do you do that? You can do that on your calculator. You can do a fraction divided by, or did I just do it wrong? Again, you guys are, I shouldn't be recording this. I'm talking. I'm nervous, that's right. Okay, anyway, you shouldn't have to use your calculator. You should be able to flip it, but whatever you want to do. You can flip it. You can just plug it into your calculator. I'm not going to make a mistake. It comes out to be 30 degrees. Is that what you guys are getting? Good. You guys are getting 30 degrees, but that's not the actual angle because the x is positive while the y is negative. That puts you in the 4th quadrant. So the angle's not 30, it is 330. I've heard a lot of people say, do we add 270 to that? We never go off the y-axis. We always go off the x-axis, right? So, final part. Let's see. the 1, we really don't even need that. That stands for the r. Cosine of 330 plus I sine of 330. And then I like putting this all raised to the what power? A -5. And we're almost done. So, it just so happens that when you take 1 and you raise it to the -5, isn't it just going to be 1 again? Right? 1 to the -5 is 1. And then what do you do with the 330 and the -5? Don't you multiply them together? And that's the cosine of a -1,650 degrees plus I sine of a -1,650 degrees. But then, can't you change that to something in between 0 to 360, right? I don't like a -1,650, so if you keep adding 360, add 360, add 360, I think you get back to 150. Should we do it? Let's just do it really quick. A -1,650, add 360, add 360, add 360, add 360. It's a -210. Add 360, or it's a positive 150. So now you're down to 1 cosine of 150 plus I sine of 150. And we already used de Moivre's theorem, didn't we? So all you have to just do is use your what now to end the problem. Use your calculator, right? And the final answers are, you don't even have to worry about the 1. The final answers are -0.87 plus 0.5 I. Final answers. And that's all we're learning for today. Any questions on what we're doing, de Moivre's theorem? Page 605, 13 through 23 odds. How many problems is that? 6. That's plenty, I think. 6 should be plenty. Depends on which form it is. Sometimes it's in complex, sometimes it's in polar.